Now we want to talk about the limit of a function. That's 2.2, limit of a function. One thing I want to just mention from the very beginning is a limit exists, a limit of a function exists only if it is a number. I can say the limit is 5. I can say the limit is 1. But if I say the limit is infinity, that does not exist. So the limit must be a number. Otherwise, the limit does not exist. So in several situations, we will encounter something like 0 over 0. 0 over 0 has hope that the limit exists. There is hope. But if I encounter something like 5 divided by 0, there is no hope for the limit to exist. This situation could be either infinity or negative infinity or DNE, which stands for it does not exist. Notice that when we're going to go into details on this. So notice that when I say 0 over 0, I'm not saying that the limit exists. I'm saying there is hope. It may still not exist. But here I'm telling you for sure, there is absolutely no hope. If you have a number over 0, the limit does not exist. What are the options? I want to look at a few graphs before we do anything else first. You choose any function from here, any graph that appeals to you from this page, and then we'll choose for the next page. So we are on page 96 now. Anything? We want to look at 5, this one? Okay, so we want to start with 5. I would also like to present this after that. Okay, so let's look at 5. Will it stay or fall on my feet? Okay. So let's take a look. Use a graph given and find each limit, and if it doesn't exist, say it doesn't exist.
I thought we did 5.
When I say that 5 is 4, why would you ever dispute that?
I was really confused. I looked up and we were pointing at 4.
Well, the following this graph is given stated that I truly know what 4 is. Trust me. One of my students, that's funny, their class starts on Friday. It's a 13-week class. So I emailed, welcome, and in the title, we start on February the 3rd. So a day later, I get an email, or 2 days later, I get an email message. Where's Canvas? I don't understand. Where's my course? I can't get into it. Where is this? Where is that? And I said, please. Class started on February the 3rd. And the message came back. Professor, trust me. I understand math more and better than I can read my emails. So don't be upset. I said, no, of course I'm not. So, okay, so we look at this graph, and we see, first of all, is this a function, by the way?
Yes.
By the
Vertical line.
By the vertical line test, this is a function. Let's look at the pattern before we look at what they ask us to determine. I follow my hand, please. So I see that the function is decreasing, and it reaches a minimum, and it starts increasing. It does not have that point there. It's an open point, as we did with the piecewise-defined function. Actually, at x equals 3, the function is 3. It has a gap, a jump if you want. The function doesn't exist here, otherwise it would not be a function. So at x equals 3, there is only one point, okay? And then it starts decreasing to whatever. Okay, so the limit of f of x as x approaches 1. This is an operator that we use, lim, limit of f of x when x approaches 1 from either side. So here is 1, x equals 1. The function gets closer and closer, closer and closer to a particular value. As x gets closer and closer to 1 from either side, the function gets closer and closer to which value?
2.
So this first answer is 2. Now we see a 3 with a power that is negative, which means with numbers smaller than 3 from the left-hand side of 3. Where is 3? Right here. So the limit of f of x as x approaches 3 from the left. X approaches 3, and here are the function values. They approach what?
I can't find it. 1.
1 from the left. Is that clear? 1. 3 from the right.
4.
4. 4. As x approaches 3 from the right, the function values get closer and closer to 4. From either side, the left-hand side you said 1, the right-hand side you said 4. What function value does this function approach as x gets closer and closer to 3 from either side?
Doesn't exist.
Exactly. The limit from the left is 1, the limit from the right is 4. What is the limit from either side? Does not exist. What is f of 3?
3.
F of 3 is 3. The function doesn't have to be defined at a point for it to have a limit. So, for example, so here's a function. What is the limit as x approaches 1 from either side from f of x? And you can see the function is not defined at 1. Who cares? What is the limit from either side?
3.
The function doesn't have to be defined for the limit to exist. So the limit from either side of 3 in the problem was this. It was an infinity, it was a negative infinity, it was exactly d and e. The limit did not exist.
That's
So
because it had different values coming
Yes.
from each side.
yes, for a limit to exist from either side, the function values have to go to the same point. Although the function may not be defined there, we don't care. As long as both sides get closer and closer to a single number. Because remember, and as we said this in the previous examples that we looked at from the previous section, we could not plug in 3 because we got an error. So we don't care about the function being defined there or not. We only care about whether we can determine the slope of the tangent line at that point. In other words, in this case, it's just the limit. It's not the slope of the tangent line. If the limit is the same from either side. So the limit exists from either side if limit as x approaches a from the left and limit as x approaches a from the right. So this is left hand limit and this is right hand limit. What has to be the relationship between these two? The limit exists from either side if and only if the limit from the left and the limit from the right both exist, of course, and are and that has nothing to do with the function being defined at that point or not. We don't care. That concept does not require the function to be defined. Okay. I like to look at some infinite limits, and also look at a piecewise defined function, as we discussed. And also I would like to look at an example like this. So first let's look at, is this 6?
Yes.
Good. Just making sure. Okay, I'm going to read because, I'm sorry,
Just for a second, can I see, I don't think I got all of that.
I'm sorry,
Copy.
I'm sorry. The limit exists from either side if the limit from the left and the limit from the right exist and they are equal. So the left-hand limit is written as x approaches a with a minus, meaning with numbers smaller than this number a, and here with plus, with numbers larger than that number a. From the right, in other words. Is that okay?
Yeah.
Perfect. So, good. I'm going to read the first part because I can't, you're not going to be able to see. So, is this a function, by the way?
Yes.
Yes, by the vertical line test is a function. These are very, very close, but it's still only one. Okay, for the function h whose graph is given, state the value of each quantity if it exists. If it does not exist, explain why. So the limit from the function as x approaches -3 from the left. I do have a pencil. I'm going to do that and erase it later. Okay, so this is 1, 2, 3, 4. This is -3. I think we see the rest, right? Okay. So as x approaches -3 from the left, do you agree with 4?
Yep. Yes.
Left, very good. From the right,
Also 4.
we agree with 4? Yes, do we see it?
Yeah.
Okay. Limit from either side of -3.
4.
Do you all agree? The left part and the right part, they all approach 4. Okay. H of -3.
Does not exist.
Indeed, it does not exist. There is no point at -3. Full point. Limit of h of x as x approaches 0 from the left.
1.
1. Do you all see 0 from the left? Okay. 0 from the right.
-1.
-1. 0 from either side.
Does not exist.
Does not exist. We agree. Okay. H of 0. 1. Indeed. That's the full point. Limit of h of x when x approaches 2 from either side. 2 from either side is 2. Do you agree with 2? H of 2
Does not exist.
does not exist. There is no point, full point at 2 anywhere. Limit of h of x when x approaches 5 from the right. 5 from the right.
3.
Indeed. Do you all see the 3? Yes? Okay, now 5 from the left.
Good luck.
D and E. It oscillates. It does this all the time. So it will be D and E from the left. Yes, it will be D and E from the left. Okay, now I would like to look at the infinite limits. Here it is. Let's look at this one. First question. Limit of f of x as x approaches -7 from either side. Do you all agree with -infinity?
Yes.
-3 from either side. Although it's D and E. But since both sides go to infinity, I have to write infinity. But the limit does not exist. It's not a number. Okay. 0 from either side. Positive infinity. -6 from the left.
+6 from the left would be negative.
Negative infinity. -6 from the right. Good. from either side of -6. I'm making that up and it's not there, but I want to hear it.
That one's DNA.
That's DNE, correct. Okay, now, what do we know about these vertical lines?
Asymptote.
Yes, they're all vertical asymptotes. X equals -7, X equals -3, X equals 0, and X equals +6. They're all vertical asymptotes. This is the definition of a vertical asymptote. When a function goes to infinity on one side or negative infinity, not both, and on the other side, it can do whatever. At least one side has to be infinity. If this side is infinity, I don't even care. I know it's a vertical asymptote. So there are 4 possibilities. Positive infinity both sides, vertical asymptote. Negative infinity both sides, vertical asymptote. And these are the other 2. Still vertical asymptote. So every time now we're going to graph later functions, when we write the limit from either side is infinity, then we know it's a vertical asymptote. Or the limit from either side of whatever, positive infinity, negative infinity, we know it's a vertical asymptote. Okay? Good. I would like us to graph a piecewise-defined function, a simple one, and then an example. Questions so far? Questions? Okay.
Oh,
Yes, yes, please.
so if you were to say you know how you usually do like h as limit h as x approaches, like say 1. If it just said like h of 3, that's when you would write DNE for that, right? Because it's the open circle.
Yes. So the limit from either side exists because the limit from the left is 3 and the limit from the right is also 3. But I will write here that f of 3 does not exist. F of 1. F of 1 does not exist, or we write f is what did I do now?
Turn your light on. There you are.
F is undefined at x equals 1. One or the other. Very good question. Is this okay? Perfect. Thank you. Other questions, please? Okay. So let's take a look at 2 examples I was on page 5, right? Yes, 26. So I would like us to look at the piecewise-defined function, very important, and an example. So I'm going to choose an example here, let's say number 16 on 97 first. Sketch the graph of an example of a function f that satisfies all the given conditions. Limit of f of x as x approaches 0 is 1. Limit of f of x as x approaches 3 from the left is -2. Limit of f of x as x approaches 3 from the right is 2. F of 0 is -1 and f of 3 is 1. And you could say, what's all this? What are you trying to do? Here's what I'm trying to do. I'm trying to instill in you the concept of the limit. So this is an example in which we're given some information and we're asked, graph an example of a function. There is more than one correct answer. Graph an example of a function that fulfills the given conditions. Outside of these, you can do whatever you want. You can put 5 vertical asymptotes if you want, or whatever. But these conditions have to be fulfilled. One thing that I want to mention is what is extremely important here, and I strongly recommend it. I will not enforce it. It's up to you. If your brain works in a different way, please go ahead. Don't do anything. But I will definitely recommend the following summary in which I will put all the information. It's a table in which I put all the information and then I come up with a graph. We're going to use this table a lot throughout this semester. for different reasons that I'm not going to disclose right this moment, because you're going to see them anyway. Okay, so first of all, I see f of 0, -1. Don't cross out like that, I'm just making a point. So I'm done with that. I put it in my table. We agree? Okay, I have f of 3 equals 1. I put it on the correct side, so I'm done with that. And the next step, it says something about 3, right? It says the limit of f of x as x approaches -3 from the left with values smaller than 3, the function approaches -2, a parenthesis, inside parenthesis -2. Okay, done with that too. To the right of 3, the limit of the function is 2, which means the function approaches 2, another parenthesis, and I put 2. Done with that as well. And this reads the limit from f of x as x approaches 0 from either side is 1. Fine. Parenthesis, 1, parenthesis. What do I put here? Excellent. So now, to me, this is very clear what I have to do. I summarize the information. I put it correctly in the table. And first of all, I'm going to start by plotting 0, -1, and 3, 1. Of course, these are my points. So 0, -1 is this point. And 3, 1 is this point. They exist, I'm told, 0, -1 and 3, 1. Now, here's what happens at 0. And let's see what happens at 3. Here's my graph. Let's see make sure that we put in all the conditions that were given to us. So the limit from the left is 1. The limit from the right is 1. 0, -1. The limit from the left is -2. The limit from the right is 2. And f of 3 is 1. So this is what I came up with. You can be fancy, you can do whatever else you want and come up with a different graph. So throughout the semester, we are going to look at the problems like these because they reinforce what we just studied. So please keep in mind, I will always present the table. I will always summarize the information to make it easier for me to explain as well, not just to come up with the example, with the function, with the graph, but also to explain what I'm doing. Okay, so now let's look at a piecewise defined function. So let's say f of x equals, and this is problem 11 on page 97. So this is 1 plus x for x less than -1. It is x squared for -1 less than x less than 1. And it's 2 minus x for x greater than or equal to 1. If you remember when we looked at the assessment, that skill, that review, basically, we said that we are going to see piecewise defined functions, and we will be asked to do certain things. And here's the question. Sketch the graph and use it to determine the values of a for which limit of f of x when x approaches a from either side exists. So we are asked to graph the function and conclude the limit exists everywhere for every point, or the limit doesn't exist everywhere for every point from either side. Well, leave that alone, so let's graph the function. When we're asked to graph a function, what is the first thought? Always forever. What do I have to determine first, for sure?
Start first point.
Please don't forget that.
Domain.
Thank you. Every time I'm asked to graph a function, I have to determine the domain. Like, for example, here's a silly example, but because maybe you will remember, if you decide to go on a trip, what is the first thing you ask yourselves? Can I afford it? Right? Or whatever you want to do. I want to buy a car. Can I afford it? That's our domain for this function, for any function. Okay, so I'm looking at this, and I will, like before, I will change it into negative infinity to negative 1 with a parenthesis. How will I change this into an interval?
Bracket.
Yes,
-1, parenthesis 1.
excellent. And how do I change the last one?
Bracket.
Excellent. Good. So now let's look at what we have and decide upon the domain. What is the domain of this function?
All real numbers.
Excellent. Nothing is missing. I have everything between negative infinity and negative 1. I have everything between negative 1 and 1. I have negative 1. I have 1. I have 1 in this branch, and everything is there. I like that. I like functions that are defined everywhere. I don't have to worry about anything. Which key x values you will have to put in the table? Because something major happens there. Yes, you are going to have other x values, but 2 are key, or the key x values, which are, of course. So -1, of course, 0 and 1, negative infinity to infinity. 0 will have to be in the table, but this is not the key point. It just has to be in the table. The key points indeed are -1 and 1. Please dictate the symbols I will write under or draw under -1.
Oh, parentheses.
Yes, a parenthesis to the left and a touching bracket to the right. So I copied this symbol and I copied this symbol already. What do I write or draw under 1?
The same symbol.
The same thing indeed. Parenthesis to the left and a bracket to the right. I know it's an overkill, but I'd like you to give me 3 functions. One that is defined on the first piece, the other one on the second piece, and the last one on the third piece. On the first piece, you can say, is your nose too long? You can see over there. That's true. I have to see them. I have to write them here. Here's why. Because these may not be in the correct order. And by mistake, I may plug in numbers between negative infinity and -1 in the wrong function. They don't have to be in the correct order. This is a correct order here, right? From negative infinity to -1 and between -1 and 1, and this between 1 and infinity. But they may try to trick us. So I recommend writing them on top of the table. So what is which function do I use for negative infinity to -1?
What's that?
Perfect. In the middle, x squared. In the middle, x squared, and the last one, 2 minus x. Perfect, excellent. So now, what type of function is this? I need 2 points. What type of function is this?
Okay.
I need 3 points. What type of function is this? I need 2 points. Very good. So let's say -2. Please plug it in and give me the answer. Please plug in -1, although you should be reluctant, but we discussed that last time. When you plug in -1, you get, excellent. Please plug in -1. Please put the 0 inside the parenthesis, not outside the parenthesis, inside, and please tell me what to write inside the bracket. Perfect. Please plug in 0. Please plug in 1. Please plug in 1. and plug in 2. Excellent. We're done.
Binary.
Say it again.
So it's binary.
Binary. Very good. It's just that a -1 is not. From left to right, please dictate the first order pair. From left to right, the first order pair, please.
-2, -1.
Next ordered pair.
It would be an open circle at -1, 0.
Excellent. Second branch, the next ordered pair. Do not extend the branches. So I cannot see something like this. It's not going to be a function, right? On the first branch, one function, in the middle, a different function, and the right branch, a different function. They are not overlapping. Okay, so first ordered pair.
Closed circle at -1, 1.
Next ordered pair.
0, 0.
Excellent. And the next one.
1, 1.
Right. You should say open. However, third branch.
Closed circle at 1, 1.
Good.
That's what it's included anyway.
And then last point.
2, 0.
So this is f of x. I would like you to identify the range of this function and then tell me if this function has a limit from either side at any point you see. On the graph. So anyone the range?
Range is 1, -50, or -50.
Excellent. From the lowest y value to the largest y value. Perfect. So now we finally answered the question, and the question was, does this function have at each and every point where, on the graph, where I want to determine the limit, does it have a limit from either side? Is there any point at which it does not have a limit from either side?
Yeah,
At which point?
-1.
Very good. So limit as x approaches -1 from the left does not equal the limit as x approaches -1 from the right of f of x. So at x equals -1, no limit from either side. It has a limit from the left. What is the limit from the left?
0,
What is the limit from the right?
1.
Perfect. But it does not have no limit from either side. From either side. It does not. At every other point, anywhere else, it has a limit from either side, except at -1. Any questions? Any questions for me? Okay. Perfect. On page 98, I would like to look at problems like 30. Limit as x approaches -3 from the left of x plus 2 over x plus 3. One comment here. Remember when we looked at Q and P? And I said, well, we determined the slope of the secant line, and then we took Q closer and closer, closer and closer to P. Correct? But we said P does not ever equal Q. So when we say, or when we write x approaches -3, from either side, from left or right, it doesn't matter, we mean x does not equal -3. Because if I accept this, then I'm really telling you that Q becomes P, but that's not the case. Q does not ever become P. Okay, so every time we calculate the limit, it's clearly specified that x approaches, that's why we don't have the equal symbol there. X approaches -3, and it's clearly understood that x does not equal -3. Okay, this was just a comment. However, every time I'm given a limit to calculate, I will plug it in. And you can say, oh, well, this is a contradiction. First you say x does not equal -3, and now you're saying plug it in. So you're saying x equals -3. So what is it? Is x -3 or it's not -3? You can't have it both ways, right? I must plug in or replace x by -3 only to see what type of limit I'm looking at. So since Omari has this handout already here on the table, look at how many, and this is not, I think it's a complete list, but I may find something tomorrow that I didn't put in here. I would not know which limit I'm looking at before I plug it in. Okay? So I have to plug it in. If I get, for example, 4/5, I'll say the answer is 4/5. I'm done. If I get -1/3, I'll say the answer is -1/3. Because eventually that's what the limit from the left and limit from the right would be. But what if I get 5/0? Now I'll scratch my head. 5/0. It's either -infinity or DNE. What do I do? So let's plug it in. Tell me what you get. What do you get at the top when you plug in -3?
-1.
What do you get at the bottom when you plug in -3? Oops. I know this situation is no hope. It's either infinity or -infinity or DNE. Only one of these three. Okay. So this is a rational function. What will happen at -3? It will definitely have a vertical asymptote. And I am asked to find the limit as x approaches -3 with numbers smaller than -3. So when I plug in a number less than -3, I'm going to say close -2.9. Is -3.1. I'm thinking of my side, I'm talking about your side. So -3.1, is that a number from the left-hand side of -3?
Yes.
Please plug it in and tell me what will be the sign of the denominator. That I'm only interested in the sign of the denominator.
Be negative.
Negative. So the top is negative, the denominator basically is negative. So what do I get?
Positive. Oh.
Indeed. That's what I'm getting. You can also graph the function and you'll see that that's what happens. So from the left-hand side of -3, it means a number from the left, which is -3.1. The denominator has to be a negative number. X plus 3 will always be a negative number from the left-hand side of -3 for sure. And the numerator is always negative in this case because it's x plus 2, and we're talking about numbers coming from the left-hand side of -3. So the top will always be negative no matter what you do. The denominator will always be negative, so we get positive infinity. Any questions on this? Okay, so let's look at 32. Limit as x approaches 5 from the left of e to the x divided by x minus 5 to the third. Again, I'm facing the limit, I'm giving a limit. I have no idea what this is. I must plug it in. Although I know I'm not supposed to, but this is the only chance for me to know what type of limit this is. If it's 5/3, I'm done. If it's 0, I'm done. Okay. So please plug in 5 in e to the x. I only need the sign. I'm not really interested in the number.
Be positive.
Perfect. So let's plug in 5 in the denominator, and you'll say, what will you say? You have to say 0. And now let's plug in a number that approaches 5 also from the left. Give me a number close to 5 from the left. 4.9, excellent. So when you plug in 4.9 minus 5, what type of number do you get here? I don't care for calculations. And when you cube a negative number, what type of number would you get in the denominator? So the denominator would be negative. So therefore, the answer would be negative infinity. It must be one of these situations.
You froze the screen.
Of course. What else? So this is always a number divided by 0. A number divided by 0 has no hope, has 3 possibilities, infinity, negative infinity, or the any. Okay, let's take a look at 34, same page. Let's see what I do now. Is there anything else I didn't put my elbow on? When x approaches pi from the left. Limit of cotangent. When x approaches pi from the left. You do not have to work with cotangent. We can go back to the simple things in life that we can easier deal with. Okay. So, again, x does not equal pi, of course. I have to plug it in to see the situation. It may be 5 over 2 and I'm done. But it may be 5 over 0 and then I'm in trouble. I have to make a decision among those 3. Okay, so pi from the left. Pi from the left means, so this is 0 and this is pi. Pi from the left is here with angles smaller than 180 degrees. So this is 0, this is 180, so somewhere before 180 degrees with smaller angles than 180. So what can you say about cosine? So at 180 is cosine is -1. So it's if I plug in pi, I get -1, right? So the numerator is -1. What about the denominator though? When I plug in pi, I get 0. So the numerator here is -1 and the denominator is 0. So I'm again in this situation. And I want to go back for 1 second and just, we talked about that, but I just want to mention it here. X equals -3 is a vertical asymptote. Here, what do I write? That x equals 5 is a vertical asymptote. Good. Okay, so then in this case, I know that cosine will not change, will be a negative number because it's the second quadrant, right? We're getting closer and closer to pi. But what is the sign of sine in the second quadrant? Sine is measured on the y-axis, positive, negative. So in the second quadrant, this number is 0 indeed, but I'm interested in before it gets to be 0. What is the sign here? Positive. So I have a negative sign forever, I have a positive sign forever. What is the outcome? So negative over positive? Negative. So x equals pi is definitely that's how my markers get they dry out. That's what happens when I'm waiting for my students to answer. So at the end of each class, when my markers dry out, you have to put 1 cent right there, the corner of the table. Okay, I'm on strike then. What does this mean? Thank you very much. Cody always saves me and my markers. Okay, one more example. I see here 36. Any questions? Omari, go ahead.
No, just your cheap markers.
Now he criticizes my markers.
You said everyone needs a sentence. Like 12 of us in here.
Yes, I mean, maybe eventually next year when I collect enough, I could get a new set. Okay. Cheap markers. Cheap markers. That does it. X squared minus 2x. The denominator is x squared minus 4x plus 4. And then the limit is when x approaches true from the left. There is a very important concept that I want to talk about at this problem, 36. So of course we are given a limit. What is the first thing that we have to do? Mandatory. Plug it in. Okay, so let's plug it in. We get what at the top?
0.
Perfect, indeed. We get what in the denominator?
0.
0. Okay. This is a different situation, right? I'm kind of excited. It's 0 with 0. There is hope. Okay. It doesn't necessarily mean that the limit exists, but there is hope. So I want to review a concept from algebra and pre-calculus. I have a polynomial, p of x. Let's say x squared minus 2x. And I plug in 0. And I plug in 2, and I get 0. What does that mean? What does that say about the polynomial? Here's a simple example, a numerical example. 9. I divide 9 by 3. What is the remainder? Remainder.
Oh, remainder.
Remainder, right? Okay, what does that mean? If a division, when I divide 9 by 3, I get remainder 0. What does that say about 3?
Factor.
Excellent. When I plug in 2 in a polynomial and I get 0, what does that mean? That x minus 2 is a factor of x squared minus 2x. Mandatory. I plugged in x squared minus 4x plus 4. I plugged in 2. I got 0. Mandatory. What has to happen? The denominator has a factor of x minus 2. What if I say x approaches negative 3? I plug in negative 3 and I get 0. What is the factor? Exactly. Exactly. So let me refresh your memory. This is the remainder theorem and the factor theorem. So note, we have p of x, a polynomial. And let's say p of negative 2 is 0. This means x plus 2 is a factor of p of x. If p of 5 is 0, can anyone give us the factor?
X minus 5.
Good. So which factor, I know I only have 3 minutes, I'll finish with this. Which factor will definitely, for sure, come out from the top? Yes. But what is the common factor that I'm...
X minus 2.
Very good. Which factor will have to come out from the denominator for sure? And of course. So when I plugged in 2, I got 0 at the top. When I plugged in 2, I got 0 at the denominator. There is a common factor in both, x minus 2 at the top and x minus 2 in the denominator. I will get rid of those. So now the simplified form is when x approaches 2 from the left of x over x minus 2. Please plug in again. Where does the top go? The top goes to
Oh,
2.
sorry.
The denominator, that's fine. The denominator goes to 0. So this is a positive number. 2 from the left. Give me a close number to 2 from the left.
1.9.
What is the sign of this expression on the left of 2? So what is the final answer? Which means that x equals 2 is? No, you care about my markers thing.
Well, I
My
had
cheat.
said it the last
My,
time. but
I didn't
remember
hear it,
the
I'm sorry. I didn't hear it. My hearing, I guess, is not as good.